Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of second derivative. So as per the problem, determine the points of inflection for the function and determine the change of sign in the second derivative. So let's start with the first function, s equals t plus t to the power -1. Now, point of inflection are points where the second derivative is either equal to 0 or undefined. So the first step here is to find the derivative of this given function. So we first find the first derivative. So the first step is, so prime of s equals, so the derivative of t is 1 plus, now for t to the power -1, we should use the power rule. So as per the power rule, we move the exponent to the front, -1 times t, and we subtract 1 from the exponent. So -1 minus 1. So we get prime of s equals 1, and then plus minus 1 becomes -1, and then t exponent -2. Now 1 times t exponent -2 is just t exponent -2. So we get prime of s equals 1 minus t exponent -2. Now we can find the derivative of this s prime to get the second derivative of s. So s double prime equals, so the derivative of 1 is 0, and then minus. Now we have to use power rule to find the derivative of t exponent -2. So as per the power rule, so the -2 exponent moves to the front, and we subtract 1 from the exponent. So we get double prime of s. So 0 goes away, minus -2 becomes +2, and then t exponent -3. Now we can move the t to the denominator to make the exponent positive. So now we have to find the t values that make the second derivative equal to 0 or undefined. So if we set the second derivative equal to 0, and if we cross multiply the t cube, so we get 0 equals 2. That means there are no t values that make the second derivative equal to 0. So now we can analyze the other case where we can find t values that make the second derivative undefined. So for that we have to find the t values that make the denominator of double prime of s equal to 0. So we can set the denominator of double prime of s equal to 0 and then solve for t. So we can apply cube root to both sides. So on the t, the cube root and the cube get cancelled out, and we get t equals 0. So this is the t value at which the second derivative of s becomes undefined. Now to find the inflection point, we should sub in this t value in the given function s to find the corresponding function value or the s value. So the s function is s equals, so we sub in t as 0, 0 plus 0 exponent -1. Now in order to simplify this expression, we should move the second 0 to the denominator to make the exponent positive. So 0 plus 1 over 0. Now we know 1 over 0 is equal to undefined because a number cannot be divided by 0. So that means this expression has no solution. That is no real solution or value. That means this function has no inflection point because we didn't get a real value for s at t equals 0. So this should be the final answer for the first function. Now we can analyze the second function. So this function is a polynomial function. So we'll start by finding the points of inflection. So for that we need to find the second derivative of this function. So we'll start with the first derivative, y prime equals. Now for the first term we'll have to use the chain rule because it has an inner function x minus 3 and then the outer function is the exponential function with the exponent 3. So we start with the derivative of the outer function. So we'll have to use the power rule. So we move the exponent 3 to the front and we subtract 1 from the exponent times the derivative of the inner function. The inner function is x minus 3 and the derivative of that is 1 minus 0 plus, now 8 is a constant, so its derivative is equal to 0. Now we can simplify this expression. Now 1 minus 0 is equal to 1. So multiplication by 1 doesn't change anything. So 1 goes away and then plus 0 goes away. So this is the expression for the first derivative. And now we can find the second derivative. So we can use chain rule again. So 3 is the coefficient of the term, so it will stay as it is. So now we'll start with the derivative of the outer function, which is the exponential function with exponent 2. So as per the power rule, we'll move the 2 to the front and then subtract 1 from the exponent times the derivative of the inner function, which is x minus 3. So the derivative is 1 minus 0. Now we can simplify this expression. So 3 times 2 is 6 times, and the exponent is 1, so we don't write it, and 1 minus 0 is 1, and multiplication by 1 doesn't change anything. So now we can find the points of inflection by subbing the y double prime equal to 0 and solving for x. So now we should divide both sides by 6 because we have to solve this equation and isolate x. So the 6's on the right side get cancelled out and 0 over 6 is equal to 0. Now we can isolate x by adding 3 to both sides. So the 3's on the right side get cancelled out. So we are left with 3 equals x. Now we can sub in this x value in the given function to find the y value for this x value. So we do y equals, so we sub in x as 3. So 3 minus 3 is 0. So the first goes away. So we are left with just 8. Now there is no x value for which the double prime of y will become undefined. So that means this function has only one inflection point, which is 3, 8. So now we can answer the second part. Now we have to find the change in sign of the second derivative. So let's start with the left side. So the inflection point is at x equals 3. So on the left side, we can use a test value 2.9, and on the right side, we can use the test value 3.1. So we have to sub in these test values in the second derivative equation and then find out whether the double prime of y is a positive or negative value. Because if it's a negative value, that means the curve concaves down on the left side of the inflection point, and if it is a positive value, that means the curve concaves upward. So let's start with 2.9. So double prime equals 6 times 2.9 minus 3. So we get y double prime equals 6, and then 2.9 minus 3 is negative 0.1. So 6 times negative 0.1 will give us a negative value. So the second derivative of y is less than 0 to the left side of the inflection point. That means the curve concaves down on the left side of the inflection point. Now we can analyze the right side. So we'll sub in x as 3.1 in the second derivative of y. So 3.1 minus 3 is 0.1. So on the right side, the second derivative of y is greater than 0. That means on the right side, the curve concave up. So we can see that as we go from left to right, the concavity of the curve changes from down to up. So the second derivative changes from being negative on the left side of the inflection point to being positive on the right side of the inflection point. So this should be the final answer for the second part of this question. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.